For thousands of years, builders have used an old technique called over-excavation and replacement to address the problem of placing buildings or structures onto weak and compressible soils. The process entails excavating and removing a large volume of poor soil where the structure or footing would be set, replacing it with stronger material, and then compacting the better material to support the footing. Upon examination of this process with its limitations and applying basic soil mechanics principles, Dr. Nathaniel Fox searched for an improvement to this traditional approach to soil reinforcement.
In 1984, I decided to develop an improvement on the ancient method of over-excavation and replacement. And there's a lot of limitations with it. It's still being used, it still has its place, but there's major limitations, economic limitations, groundwater limitations, undermining of additional buildings or nearby building limitations. So I knew something should be done to create a better method than that. In doing this, I developed what is now known as Geopier soil reinforcement, or Geopier intermediate foundations.
The unique aspects of the patented Geopier foundation system are the process and the tamping system. The process first involves drilling or excavating a cavity. Drill depths normally range from about 7 to 15 feet, depending on design requirements. Once the cavity is completed and a volume of compressible soil is removed, a small volume of clean stone is dumped into the bottom of the cavity. A special tamper is then activated on the surface of the clean stone. The tamper uses impact ramming energy to pre-stress and pre-strain the soil at the bottom of the cavity while making a bottom bulb. Well-graded highway base course stone is then introduced into the shaft of the cavity in thin lifts of 1 foot thickness. The tamping system again uses impact ramming energy to compact the aggregate. A specially designed beveled tamper pushes the stone laterally against the soil, increasing the lateral stresses in the adjacent soils, and thereby strengthening the Geopier foundation element being installed.
The method of installation builds up lateral stress in the soil, and we believe this is pretty important because the more you confine a soil laterally, the stronger it is, and the less compressible it is. And we believe this is a major feature that tends to minimize the settlement of the Geopier foundation system. Lateral stress also affects bearing capacity. In fact, our bearing capacity equations are built on the premise that it's not the soil underneath the foundation that holds it up, it's the soil alongside that keeps the soil underneath from squeezing out. Now, if we can further confine that soil with lateral stress, we'll end up with a higher bearing capacity.
As a load is placed on the footing supported by Geopier rammed aggregate piers, a slight settlement occurs. The Geopier elements compress and bulge slightly, which causes more lateral stress buildup and strengthens the elements even further. The site of a 5-story AAA baseball stadium in Memphis, Tennessee, is one example of how Geopier foundation systems are now being successfully used.
Geopier foundations were used at this site because the project geotechnical engineers thought that shallow foundations would not provide enough foundation support, and yet deep foundations were deemed to be a foundation overkill. What we have at this site is 30 feet of soft silt and clay. We have a 5-story structure, column loads are relatively high, and so what we needed to do is provide a foundation system that was going to support that structure on these soft clays and yet not lead to excessive settlements.
The approach chosen for the project was Geopier soil reinforcement, calling for the installation of about 1,200 Geopier rammed aggregate piers to support high-capacity footings. Because Geopier elements replaced the need for deep piles or deep concrete piers, the foundation cost savings to the project were approximately $500,000.
Geopier foundation systems are attractive for three reasons. The most appealing reason is that they're less expensive to install than deep foundations. The second reason is that they're quicker to install than deep foundations. And the third reason is we can work in the rain and in difficult weather conditions and thus facilitate the project schedule.
Originally, the idea of Geopier soil reinforcement was to take an unsuitable weak soil and make it suitable to support a shallow foundation. And now, 15 years after the original concept was being developed, we find that about 40% of our projects are in poor, unsuitable soil areas where we're reinforcing the soil to support low to moderate loads. However, 60% of our projects are now in fair to good soil areas with heavy loads. The loads are too heavy for standard shallow foundations. The highest buildings we're presently supporting are a 16-story hospital tower, a 15-story office building, and then various buildings in the 11, 12, 13-story range. The heaviest loads we're supporting are 2,200 kips, 2,000 kips, 1,800 kips in that region.
The Geopier system is nothing fancy or complicated. It's merely an improvement and refinement to the ancient method of over-excavation and replacement. Geopier rammed aggregate piers constitute an intermediate foundation system, in between shallow foundations and deep foundations. It has two primary advantages: cost and performance.
Up until now, a consulting geotechnical engineer has one primary question to answer on every design project that he does, and that is, can this structure be supported on shallow foundations, or does it need to go to deep foundations? In other words, is it an inch or is it a mile? Now he has another option. Does it have to be deep foundations, or can it be intermediate foundation and less expensive and more practical?
Geopier soil reinforcement is cost-effective and consistently performs within project design requirements. Ongoing research and successful performance of tens of thousands of Geopier elements prove the viability of this innovative soil reinforcement system.